Welcome back, students, to our course on industrial organization. Today we are going to start our discussion of monopoly practices in more detail. So I gave you some refresher on what is called or what our market structures are, competition and monopoly. And today we go beyond what we did in this refresher on the monopoly, on where we looked into what is called uniform pricing. Today we are looking into what is called price discrimination, more sophisticated monopoly pricing strategies. I think economists typically call that price discrimination. Marketing people might be more tempted to call it only price differentiation because that doesn't sound as bad. And we will focus here only on a monopoly. We get back to price discrimination in an oligopoly once we discuss horizontal product differentiation. Okay, but to start with, it's sufficiently complicated to look into price discrimination of a monopolist. Okay, so what are we dealing with? We are dealing with an ubiquitous fact, namely that the same product sells at different prices to different consumer groups or something like that. The example here Pebble Richard Norman gives is that prescription drugs are cheaper in Canada than in the United States. I think there are even regular bus tours who go from some US city to Canada to buy the prescription drugs, where we also have huge differences in terms of prices of pharmaceutical drugs in Europe. What you also will learn is, once you ever have been to the US, is that textbooks are terribly expensive in the US, and they are generally much cheaper both in Britain and also in continental Europe. So what you observe is what economists call price discrimination. Companies charge different prices to different consumers for the same product. Okay, so this is our definition of price discrimination. Why are firms doing this? Because it's profitable. Okay, that's why are they doing this? And the another question is, of course, is that a good thing or a bad thing from the viewpoint of society? And that's in particular the question of efficiency. And it's not so obvious that it's a bad thing in terms of efficiency. The problem here is that some consumer groups will gain because they pay a lower price. Others will lose because they have to pay a higher price. So the overall effect, in particular on welfare, is not clear, even though the question is always whether this is fair, because some consumers pay a higher price, whereas others get a better deal. Okay. What is also interesting here is in terms of policy. How does policy react to price discrimination? In the US, we have particularly what is called the Robinson-Patman Act, and this prohibits price discrimination only if it is intended to lessen competition. We might get back to that. And this is somehow comparable to what you see in the European Union. Here in the European Union, so it's also forbidden if it's meant to lessen competition, in particular if it raises rivals' cost or something like that. What is an additional aspect in the European Union is that we have these single market provisions, namely that we want to have a single market, and therefore in particular restrictions on parallel trade or something like that are excluded. I will get back on the next slide to this parallel trade. But before I do that, I want to give you just a quote from Walter Eugen, which is one of the founding fathers of what is called ordoliberalism, and also of our German, what we call in German Wettbewerbsordnung. It's difficult to translate that into English, probably more like the regulatory framework or the frame of our economy. And he stated in his Grundsätze der Wirtschaftspolitik, so in his principles of economic policy, that in der vollständigen Konkurrenz bilden sich bekanntlich für gleiche Waren und Leistungen gleiche Preise. Indessen haben zum Beispiel Angebotsmonopole im Streben nach der höchsten Reineinnahme die Tendenz, Preisdifferenzierungen für die gleiche Ware oder Leistung von den einzelnen Schichten der Nachfrage zu verlangen. Und dann seine Schlussfolgerung, diese Preisdifferenzierungen sind in der Wettbewerbsordnung zu verbieten. So to translate it briefly in English, under perfect competition you would have the same price for the same product, whereas monopolists try to increase their profits and therefore they also use price discrimination. They charge a different price for the same product to different groups of consumers, and he concludes that you should prohibit such price discrimination. Okay, of course we see it's not prohibited, but or at the end of this lecture and next lecture you should have an idea why it would a bad idea to forbid or to prohibit this kind of price discrimination. Okay, so given that price discrimination is not forbidden, and given that it's a frequent business practice, which is done by businesses because it's profitable, of course, we want now have a closer look into, or more detailed look in, how price discrimination works and what the preliminaries or the prerequisites for price discrimination are. There are two important concepts or terms here. The first is identification, the second is arbitrage. In terms of identification, of course, the firm, if it wants to price discriminate, it needs to be able, first it must know its demand function, but then it also needs to be able to identify the demand curves of different types of consumers or of different markets. Okay, and that's easier in some markets than in others. Your tax consultants will rather well know about your income and so on. Your doctor might also know that. My kids used to go to the Kieferorthopäd in German, so in English it's orthodontist, and of course she will always know, oh, these are the kids of this professor, and therefore they have a rather high willingness to pay for their braces. Okay. So they might be able to identify your willingness to pay, or the willingness to pay of different groups. The second point is that even if you identify different willingnesses to pay, you know that, for instance, students have a lower willingness to pay for a certain product than have professors or other people, then you run into a second problem, namely the problem of arbitrage. What you need to be able to is that you need to prevent consumers who are charged a low price from reselling to consumers who are charged a high price. Think in terms of our students. If you sell tickets to a certain event cheaper to students, you need to be able to prevent that these students buy these tickets and resell it to their professor. Okay, that's what we call arbitrage if they do this reselling. And this is also important in terms of if you want to sell a higher your prescription drug at a higher price in the US, you need to prevent reimportation from Canada. And there are actually many cases in that respect, because in particular within the European Union, for instance, large car companies like Volkswagen or Daimler tried to, or very often or for a long time, sold their cars cheaper, for instance, in Denmark or in Italy. And what they did is they didn't allow Italian car sellers or retailers to sell to German or Austrian customers. Okay, and I think in the notes I gave you an overview of one of the cases in Europe, and I think Volkswagen, and I just have to look it up, was charged a fine of 100 million euros because it tried to prevent this reimportation. So due to these single market provisions, firms are not allowed to prevent consumers from going abroad and buying the product there. Okay, that's of course a prevention or a prohibition of price discrimination. Okay, because what you see is if you have sizable differences in terms of prices between two consumer groups, in that respect of Volkswagen German consumers and Italian consumers, you need to make sure that German or that consumers you want to charge a high price cannot buy at the low price. Okay, that would mean that you prevent arbitrage. Okay, suppose you are able to identify your consumer groups and you are able to prevent arbitrage, then firm has to choose how to price discriminate, which type of price discrimination to choose. And actually, as you see from the first three terms, economists for a long time have not been very creative in giving or providing some nice description of these different types. They called it first-degree price discrimination, second-degree price discrimination, and third-degree price discrimination. We will deal with all three degrees of price discrimination in today's and next week's lecture. But actually, finally, in 1998, Hal Varian, chief economist now of Google or Alphabet, and Carl Shapiro published their book Information Rules, and they came up with more telling terms. First degree price discrimination they called personalized pricing, and you will see why that makes sense. Second degree pricing they called menu pricing, and again I will tell you how that is. That's actually what you see in terms of the contract you typically have with your mobile phone company. And the third degree pricing is what is called group pricing. And that's rather straightforward, because here you will see we typically look into two different groups like students and other consumers and look how price discrimination might look like in this case. Okay, so what we want to start with here is third degree price discrimination. What does it mean, or what does it require? First of all, you know some demand, and you know that consumers differ by some observable characteristics. So you can identify two different groups, for instance. So what that means is that, for instance, you know that your students must have a student ID. Okay, and how does the pricing rule look like? You charge a uniform price to all consumers in the same group. Okay, all students pay the same price. All other consumers also pay the same price, and this is a linear price. What does a linear price mean? It is the same price per unit of output, irrespective of whether you buy 10 units or buy 100 or 1,000 units. Okay, later on you will see what a nonlinear price is, but here this is a standard price. Okay, and here you just get some examples which are all taken from Pepper Richards Norman. Kids are free, so that would mean that families get a better deal than just couples without kids, for instance, if they go for dinner. What you see very often is for professional journals like the American Economic Review. Here you have discrimination based on income, actually. It's the case that students pay less than assistant professors, and assistant professors pay less than full professors. Of course, this requires that full professors correctly reveal their type, okay? But of course, no full professor probably will claim he's or she's only an assistant professor in a sense. That's how that works. In airlines, you very often see that you have many different fares here, and they might differ on the time when you book and so on whether you stay over the weekend, etc., etc. You might have early bird specials, or in Germany, typically we call it happy hour for some reason. So you pay a lower price when you enter something, or when you go to a bar rather early in the evening, or if there is no corona pandemic, or if it's very late. Okay. What you also have in the US is first run of movies. We more or less have not something like that, as I know, but if you go to theater, you often pay a higher price if you attend the premiere. Okay. So many examples. Every time you go to the city and buy something, you will see very often some price discrimination is going on. Okay, so how does third degree price discrimination, how does group pricing work? What is the essence of third degree price discrimination? The point is, you charge consumers with a low elasticity of demand a high price, because they won't stop consuming your product or won't reduce consumption significantly compared to a lower uniform price, because they react inelastically. On the other hand, you charge consumers with a high elasticity of demand with a very low price or with a lower price, because that means that these consumers will expand compared to the higher uniform price, their demand by a large degree. Okay, that's what happens, and by this demand expansion you can get or you can increase your sales. Okay, yeah. Here we just want to start with just solving this problem analytically. Actually, that's probably what you should have, or hopefully you should have done in already in your intermediate or in your undergraduate IO course. So we start just very, very generally. And we start generally here with just two separate groups, okay, only the case with two groups or two markets, so students and other people, German customers, Austrian customers, and so on, whatever you want, business customers, residential customers, and they just have different demand functions. You as a firm know these demand functions, and you can distinguish between these two groups. So the demand functions of Group 1 is just Q1 as a function of the price 1, and demand of Group 2 is a function of the price 2, and aggregate demand is just the sum of these individual demands. And profit maximization with uniform pricing, no price discrimination, means that you charge a single price. Here we just maximize profit. You know, with a monopolist you can always charge the optimal price and then get the optimal quantity from the demand curve. In chapter 2 we choose the optimal quantity and then we solved for the optimal price from the demand function or from the demand curve. Here, in a sense, it sounds a bit more natural if you speak about price discrimination to do the optimization in terms of prices, but actually it doesn't matter. Okay, you can do both. But here, just do it in terms of prices. So what you see, we maximize profit, which is nothing else. So this is a quantity 1 times price. So this is revenue from Group 1. This is revenue from Group 2 minus the cost of this Q1 is nothing else than D1 of P1 or of P in this case, because we have the same price. Okay, I just didn't want to write all that here because it gets terribly then. But if we take a derivative here, if we maximize, we get our first order condition by just taking the derivative with respect to price. So we apply a product rule here. So we get this expression here, d prime 1 times P plus, if we take a derivative with respect to P, we just get D1. The same for the revenue of, or revenue with the derivative of the revenue of the second group with respect to the price, minus here the marginal cost, which is a function of Q, of course. The marginal cost is a function of output, but output is a function, of course, of price. That's why we have to apply chain rule here. Okay, we get dC dQ, then dQ dP, and then we get this change here. Okay, just note here, this looks a bit like marginal revenue, but it's not. It's because it's a derivative with respect to price of the revenue. Marginal revenue is the derivative with respect to quantity. Okay, but now what we are doing next is just rearrange this here, dividing here, putting this expression with C prime with the marginal cost on the other side, taking or dividing by d prime 1 plus d prime 2, and we get this, and we factor out P, and we get this well-known Amoroso-Robinson relation, where this expression is nothing else than -1 over the aggregate demand elasticity. Okay, this is what we derived up there. This is nothing new. Okay, the only thing is now that we have these two groups. Okay, but again, as we don't distinguish them, we just aggregate it and just get aggregate demand elasticity. This is something I don't know on which page or on which slide we already derived this condition. Okay, here, of course, it might be more complicated because we might get corner solutions, but I will get back to that later. To begin with, this is just what we want to look into. Okay, this is what we get here. This is our standard, our benchmark case. What is more interesting, of course, and what is new now, is what happens if we charge different prices to the different groups. Okay, and the different prices to the different groups, again, we maximize our profit, revenue 1, revenue group 2, and now we take the derivative with respect to different prices, price 1 and price 2. And what we obtain here is, of course, two first order conditions now. Now the first order condition with respect to price 1, and you see it's very similar. The only thing is that it's now just the one group which gets its price. And again, it looks very similar to marginal revenue equal marginal cost. Actually, we just have to put this marginal cost on the other side with a minus and divide by d prime. Then we actually get what we had in the above result as well. So this is nothing else than marginal revenue is equal marginal cost. And this result tells us marginal revenue from product 1 needs to be identical to marginal cost. And this is identical to marginal revenue of product 2. Okay. So here you get the same terms, or you get marginal revenue is equal in both markets or for both groups. Okay. That's what we have. Should be clear, hopefully. And what we can do, of course, then here for this is just -1 over the elasticity, but now for this market, and we define this elasticity here as eta I, okay, or eta 1 would be eta I would be just d prime 1. Did I say eta? Oh, it's too ugly here. Eta I would be d prime I over di, and then we have a pi up here. Okay, that's what we have. And so, and of course, I always forget the minus because it's so obvious. We have to use the minus as well, because we also always define it in absolute terms. Okay, and now what we did, if we substitute that here, that eta I, so these group price elasticities, we get here, of course, this 1 minus here for this right-hand part here, or for the left-hand part, we get just this Amoroso-Robinson relation here. And what we have here is P1 times this relation is equal to marginal cost, and is equal to P2. And what we do here is just leave that marginal cost out, divide by P2, and also divide by this expression here and put it on the other side. That's how we get this ratio here. Okay, and I probably confuse you right now, but that's how you get from this condition this ratio. And this ratio is nice because if you put that on a common denominator, what you get is this expression here. Okay, you get this expression, just check it at home. And what you see here is immediate result. The price is lower in the market with the higher demand elasticity. Okay, eta 1 times eta 2 is the same in both, and if product 1 is has more elastic demand, that would mean eta 1 is larger in absolute terms than eta 2. So we would subtract more here, and therefore the term in the denominator is larger, so P1 over P2 would be smaller than 1. Okay, that's our key result here. And that's just the formal proof, in a sense, of what I just explained to you, that the group which has a higher elasticity of demand will pay a lower price. Okay, that's about what I wanted to pay you here, to tell you here. I think there's nothing else in the in the notes. Yeah, and that might have been a bit abstract, but it will be straightforward. In the assignment, we will have just some problems where you can derive that. Here in a slide is also an example for the case of linear demand curves. Here, the example Pepple Richard Norman use here is that the book of Harry Potter is sold in the US and Europe, and you have different demand functions and you have a different marginal cost. I don't want to go through this detail. You have the slides here, but you will do this here, for instance, the calculation anyway in one of the assignments. What I want to do is just to show you here the graphic solution of that problem. Okay, that's why I jump back from slide 96 to 104, because it's a nice way to illustrate this problem. So you start with the demand in the two different countries. So you see you have two different demand functions in these countries. You always just also depict the marginal revenue curve. And what you're doing then is just also drawing the aggregate demand curve. Here you see with the aggregate demand curve, if you have different cut-off prices, you will have a kink here in a demand curve, and a kink in a demand curve translates into discontinuity in a marginal revenue curve here. But here the result is rather straightforward. If we look for the uniform price, of course, we need a marginal cost curve, which I just came here with 4. If you have the marginal cost curve, you will see, I don't know where you saw this here, you can go down to the respective aggregate output, go up to the inverse demand function. You see that the price, the uniform price will be 17, and then you just look into this price, what the output is here. If you have a price of 17, you will sell 4.75 units in the US and 1.75 units at this price in Europe, and this gives you an aggregate output of 6.5. This is our uniform price. This is what is also derived formally in a previous slides here. What you could do then is just to look what the price is if you allow for price discrimination, or if you price discriminate, and then of course you will set equal the marginal revenue in each market with the marginal costs. And if we start with the US, you see marginal revenue here at this price or at this output of 4.75 would be below marginal cost. Okay, it would be at 0. And of course, that's not optimal in terms of profit maximization. If you're able to price discriminate, you reduce the output here until marginal revenue is equal marginal cost. You get then an output of 4 and a price which is higher. Oops, I was too quick. A price which is higher, which is 20. Okay, and in Europe, at a price of 17, marginal revenue is way above marginal cost. So what you do is you expand demand until marginal revenue is equal marginal cost. You get a higher output of 2.5 in this case, and you get a lower price of 14. Okay, so what you see is that we get price discrimination. It's optimal. Of course, it must increase profit, because otherwise you wouldn't do it, or it wouldn't be optimal. What you saw here with this comparison of marginal revenue with marginal cost at the uniform price, you saw that in both cases we were able to increase profit. Okay, and that's what you also see if you just calculate it formally. Yeah, and one final point here. I didn't say you anything or didn't tell you anything about price elasticity. Where do we have higher price elasticity? What is, do we see that? Obviously, from the result, we see that demand in Europe is more elastic than demand in the US, because the price is lower in Europe. But can we see that directly? Actually, what you saw, and if you remember, perhaps both demand curves had the same slope. They had a slope of -4 here, so they have the same slope. But how do we see that demand is more elastic in Europe than in the US? Actually, you know that along such a linear demand curve, up here at the cutoff price, you have an elasticity of -infinity. Okay, and down here at the price of 0, you have an elasticity of 0. Okay, and at 1/2 exactly, this would be about 18, you would have an elasticity of if it, of course, I have to get rid of the minus if I do it in absolute term, you have an elasticity of 1. And so you see immediately, if you have this, two demand functions and one demand function, and both demand functions have the same slope, but one demand function has a lower vertical intercept, then it's clear that this demand function with the lower vertical intercept is the more elastic one, because here you have the elasticity of infinity right here, okay, and an elasticity of 1 at about, this would be about here, okay, and for each price you get then, of course, a higher elasticity, because here you have some positive elasticity at this price, and you have an elasticity of infinity in Europe, okay? That's how you can see that for linear demand curves with the same slope. Okay, that's about what I wanted to tell you here. What we see and how we can sum up here is that, and I don't know, hopefully you got that among all the numbers which I told you, you saw hopefully that aggregate output is always the same here, irrespective of whether we have price discrimination or not. And that's a rather general result. It always comes up if we have linear demand. We will have a different result if we allow for instance, isoelastic demand curves. But for linear demand curves, third-degree price discrimination always leads to the same aggregate output. But, and that's what I already told you, why is this firm engaging in price discrimination? Because it can increase its profit. And I added some information I previously had only in the notes. What about consumer surplus? And you always should check this result, because I did it rather quickly, so might always be that I make some mistake. Here I just calculated the consumer surplus with the uniform price and with price discrimination. What we see here, this is a consumer surplus in the US. This is a consumer surplus in the EU. You see two results. First of all, consumer surplus goes down. Okay, that's also rather general in a sense with this kind of price discrimination with linear demand. And however, Europeans like price discrimination because their consumer surplus increases almost or more than doubles, whereas the US consumers, they lose. Okay, clearly. And that's what you see. And finally, what about welfare? And perhaps you might have guessed that even the change in welfare is not very large, but what you see is the increase so this would be the profit, and the increase in profit is lower than the loss in consumer surplus. So what happens here in this example is that price discrimination reduces welfare. Okay, that's what we see here. Later on, you will see many or the circumstances under which the opposite might hold. Okay, but here we see that price discrimination reduces welfare. Okay, yeah, here just a smaller side. What we assumed were constant marginal cost. You might also look into the case in which the marginal cost is not constant but increasing. Here's some details how you're doing that. If we just do that in formal terms, with an analytical solution, it's straightforward to do that. Here, just have some constant margin, some marginal cost, which has some constant plus an increasing term in quantities. So what we are doing here is just what we see here. It's increasing the marginal cost function. In terms of the standard monopoly, it's no difference at all. That's what we even very often assumed in our benchmark model above. Once we look into the case where we allow for price discrimination, it's a bit more complicated, because what we have to do is we have to first aggregate marginal revenues, and we do that horizontally. Okay, we do that in this direction, and then set equal this marginal revenue equal to marginal cost. So then we get the output, and when we jump back here and get the result. So this is just a small technical aside. Pepper, Richard, Norman use here parameter values so that you get exactly the same result. So anyway, the point is you should increase at least in principle, be just able, if you get a demand function like this, would the demand function be, for instance, like 0.75 times Q plus Q squared, okay, which would exactly give you this, and you should be able to calculate the result. But if you put that in your maximization problem, no problem to calculate it. Okay, so what I already told you, and this is again a summary, if demand is linear, price discrimination results in the same aggregate output as no price discrimination. We could have also shown that by just using some P is A minus BQ or something like that, just some standard or some more general linear demand function. And price discrimination increases profit. As a rule here, in terms of profit maximization, it holds that marginal revenue must be equal in each market, and marginal revenue must be equal to aggregate marginal cost. Okay? So this is our standard result in a sense. And now we are moving on, and of course, what we saw is that price discrimination is a good thing in a sense for firms, because it increases profits. So very often it's not so easy that, you know, here are students, here are other people which have a different willingness to pay. So you might think hard about how you could discriminate between consumer groups. And one frequent way to do that is to sell, in a sense, slightly differentiated products. As you see here, you might sell a book not only as a paperback, but also as a hardback. So because you might think, so people who really value that book very much, they rather go for the hardback version than for the paperback version. You might introduce first class versus economy class airfares for your flights, okay? So here we just, or what we are doing here is we just extend our basic approach and allow for, where does it stand here, for different costs in a sense. Okay, because the hardback probably is more expensive than a paperback to produce. First class at least typically gives you better lunch or a better dinner. Okay, you get better food, and you might even have a more spacious seat. Okay. And so what we get here is that we sell two different products, or differentiated products with different prices. With different costs. So what does price discrimination mean in this case, or under what circumstance does a price discrimination exist in these cases? We use the definition of Flips here. He defines that two varieties of a commodity are sold by the same seller to two buyers at different net prices. Okay, and the net price is the price paid by the buyer corrected for the cost associated with the product differentiation. So if the hardback costs 30 euros, the paperback costs 15 euros, and the production costs are 5 and 6 euros, so you see that it's a huge price discrimination, because the net price in the one or the net margin would be 10 euros in one case, and 30 minus 6 would be 24 in the other case. Okay? So here you see you have, even though you sell two differentiated products, it's not the same product, but nevertheless here, once you are able to compare the cost, you can determine whether there is price discrimination. Of course, again here, the seller needs an easily observable characteristic that signals willingness to pay. And the seller must be able to prevent arbitrage. So business customers typically pay more for their flights. But the point is that business customers in the time, in non-pandemic times, move there and back on the same day. Okay, whereas tourists typically stay overnight or stay over Saturdays and so on. And you very often you also have to try somehow to make stay over the weekend compulsory, that you prevent arbitrage for business customers, for instance. Same problem, okay? And there is another very nice, I think, quote from, I worked hard, Jules Dupuis, whoever can pronounce that correctly. It's a French guy, and he wrote, it's a French water engineer or construction engineer, and he wrote a very important piece already, or published it already in the 1840s. It was on the measurement of the utility of public works, and what he said is that French railways at that time had a third class, and this third class didn't have a roof, and they had wooden benches. And what he said, it is not because of the few thousand francs which would have to be spent to put a roof over the third class carriages or to upholster the third class seats that some company or other has open carriages with wooden bench. It would be a small sacrifice for popularity. What the company is trying to do is to prevent the passengers who can pay the second class fare from traveling third class. It hits the poor, not because it wants to hurt them, but to frighten the rich. And that's what he wrote, 1834 or something like that. Prevent arbitrage, and you see, to prevent arbitrage as a firm, you might have to hit to hurt the poor, okay? Even though you want to hit the rich or frighten the rich. Okay, that's what we have here. Yeah, once we have this kind of different marginal costs, here we just provide a very short formal description of that problem. Again, assume we have linear demand in both markets, but now this demand might be slightly different. Assume that we have different marginal costs. So the costs for economy class travel or an economy class seat is slightly lower than for a business class seat, or for a paperback is lower than for a hardcover. And yeah, here's just, I never buy paperbacks. So here you need to be able to identify and segment this market. Okay, and what you're doing is you equate marginal revenue. Here we take the derivative with respect to quantity. You know, in each market you will get just Q is A plus C over 2B over 2. Okay, that's what you always get. That's the standard monopoly price, but now you charge a standard monopoly price in each of the market, and here you get a price difference. And you see here the point is that this price difference depends on both these vertical intercepts, A1 and A2, and on the cost difference. And once, first of all here, what Pepperchett Norman state is that it's highly unlikely that the difference in prices will equal the difference in marginal cost. Okay, what does this mean? As soon as there is a difference in cost, you will have a difference in prices. Whether you call this price discrimination, you just apply your same markup to different costs, or whether you called it something different, is more like a semantic rather than an economic question. The important point is, once you get differences in willingness to pay, you will have a significant price difference or price difference. Yes, that's what you have. you charge the two products at a different price. And this holds even in the case in which the vertical intercepts, the maximum willingness to pay of both consumer groups is the same. That means if A1 is the same as A2, if you have different costs, because you have, you put a markup of 50 or of 1/2 here, that's what you have. Okay. I think here there are, before I make a break, I just want to tell you a very closely related point here. And there are several ways to implement price discrimination, okay, and to control arbitrage. I already told you, you want to have a Saturday night stay. You don't allow for cancellations of your tickets if you're a tourist, whereas you pay a very high price ticket if you want to get cancellation storno, okay? You might have personal use only for academic journals. They charge our library much higher than they charge me personally, but I'm forbidden to share my copies with you students, for instance, okay? And the time of purchase, of course, is very different. So if you attend a prime time movie at the cinema, it's more expensive, and during a dinner time you don't get the cheap lunch menus in a restaurant. What is one of my favorite is crimp the product to make a lower product, to make a lower quality product. Mathematica is one case. There's a famous paper by what Danneker's first name is, I don't know at the moment, Raymond Danneker, and Press McAfee in the Journal of Economics and Management Strategy in 1996. It's called Damaged Goods. And what they show is our previous case with the different costs also applies in that respect, in where you have a group where you have a higher willingness to pay for one group. But what you're doing is actually you produce a second product for the low willingness to pay the group by destroying, in a sense, or by damaging the quality of the high quality product. I have here the Mathematica software, so they also have a general version or a full version and a student version. Of course, how do they produce the student version? They have the general version and disable some properties, okay, and it costs them extra. The example Danneker McAfee give, there's an IBM laser printer, and they just disable some functionality in order to destroy that or to make a lower quality version. If you buy a new car, it typically has enabled many, or it has integrated many nice features, and it tells you go to your dealer, and this dealer can just then enable these features. Okay, there was I think there was an Intel 386 SX and DX, which was before the Pentium processor was. The DX was called to be with a mathematical coprocessor. The SX was without a mathematical coprocessor. Actually, they both had a mathematical coprocessors, but in the SX machine it was disabled. So the point is, they produced a lower quality product by first producing the high quality product and then engaging in or using up additional cost, and then reducing therefore the quality, and therefore selling it to people with a lower willingness to pay. Okay, so you have to be rather creative as a firm. The next point I will look into is discrimination by location, but before I move on, I just want to make a short break and ask for questions in up to now in WebEx. Okay, yeah, welcome back here. We already had some discussions about what the government does about price discrimination, in particular about price discrimination between in restaurants, between lunch and dinner. Perhaps I just move on here in terms of price discrimination by location. Suppose you have two distinct markets, call them Austria and Germany, or French and Germany, and you are located in some market, you're a German producer, you have pretty much the same demand function both in Germany and in France, but the point is, once you sell to France, you have higher costs because you have to transport it there, okay? And then simply what we get is you equate marginal revenue to marginal cost in each market. And in Germany, you don't have these additional transport costs. You just have A plus C over 2 as a monopoly price. In France, you have an additional markup due to the transport cost. And so there is a price difference, which is half of the transport cost difference. Okay, so you have a difference in prices, and this is not the same as a difference in cost. Whether you, as this relates to the standard markup, at least Flips calls it price discrimination. You see it's different prices. Okay, and again, what you see, and here I get back to our case of selling cars in different markets. Here you also have, if Volkswagen sells cars in Italy, so suppose you not only have here these price this difference in transport costs, but also the differences in these AIs, in this maximum willingness to pay, then you will have rather different prices between Italy and Germany, and that's what actually Volkswagen wanted to have, different prices between Italy and Germany, and in a sense extract consumer or willingness to pay of German consumers, and they didn't allow, or we wanted to prevent German consumers from buying in Italy, and that was an example I gave you in the very beginning when I told you that Volkswagen was fined with about 100 million euros for these abuse of it's not a dominant position, it was just a violation of antitrust laws. In this case, it was a violation of the single market provisions, that you are not allowed to prevent reimportation. Okay, transport costs are also important. You will see we have transport costs also in one of the assignment. Transport costs are typically just an instrument to prevent arbitrage, because if you think typically jeans or a pair of jeans is much cheaper in US than it's in Europe, but probably it's too expensive to go there to just buy a pair of jeans, because the transport costs would be very high. But of course, this wouldn't prevent just some smart businessman, some smart entrepreneur who just starts then a business, buys the jeans cheap in US and then ships them in bulk to Europe. Okay, so here it's always an interesting discussion as in how far transport costs can act as a device to segment markets. Okay, welfare. That's what we already started. So the question is, does third-degree price discrimination reduce welfare, and therefore do we have a good argument to prevent price discrimination as a government, say? And of course, this is something different as being fair. I already told you that students never should oppose price discrimination, because they usually gain from price discrimination. We only look into total surplus and into efficiency. What is the impact on efficiency? Of course, you might always think price discrimination is always a good thing, because richer people typically have less elastic demand, so it hurts the rich and benefits the poor. Unfortunately, this is not always the case. If you think in terms of complicated tariffs from mobile phone companies, from your natural gas supplier and so on, they might have rather complicated tariffs. And what we saw in behavioral economics is that very smart, value-educated people are more able to benefit from complicated tariffs than are less well off and say less educated people who very often end up paying higher prices once we allow for price discrimination than these smart guys. So in that respect, it might even hit the wrong people, this kind of price discrimination. But the question is here, does monopoly price discrimination worsen your monopoly problem? Does it even lead to additional deadweight loss? And here I just want you to show a very nice kind of analysis which was introduced by Richard Schmalensee in a paper in American Economic Review in 1981. Called Output and Welfare Implications of Monopolistic Third-Degree Price Discrimination. And he has a very general and very simple setup. He distinguishes between two markets, a weak market and a strong market. Here you see the weak market is called weak because here the marginal revenue and the marginal cost, you see immediately the price in the weak market would be a low price. The high in the price in the strong market would be a high price from the viewpoint of the company. The shape here doesn't matter much, but you will see that it has some meaning here. What we can do, so the uniform price, of course, is something in between, what is obvious. And here, what is also very important is this change in terms of quantity. So in the weak market, if you move from the uniform price to price discrimination, output increases, and in a strong market, output decreases. Okay, and now what we are doing is we get some upper bound on the gain we get from price discrimination. And the gain we get, of course, from price discrimination in the weak market. So what you see here directly, the gain in terms of consumer and producer surplus would be just about these trapezoids. That's how it looks like. Okay, that's about in more detail or collective for this shape of demand curve. It would be the gain in terms of total surplus, namely consumer surplus. This would be this triangle, and producer surplus would be this rectangle. Whereas here, this part here would be just redistribution. Okay, from the firm to consumers. But anyway, in terms of total surplus, this would be the gain. But of course, we want to have some measure which is an upper bound, and that's what Schmalensee introduced here. This G is just an upper bound of the gain. It can never be larger than the original price here times the change in quantity. That's the gain, the maximum gain in terms of surplus. Similarly, we can depict the minimum loss. So the loss is in the other market is at least this here. Actually, it would be plus this triangle, but of course, we want to have a lower bound, so we know that it's this loss here. So if we start from the uniform price, and we know that this is the reduction in terms of output, we know irrespective of how this demand function looks like, okay? I don't know whether you got that this is supposed to be different demand functions. Irrespective of how these demand functions look like, you get at least this loss. And that's what we are just now looking into. We'll want to look in an upper bound for the change or for the increase in welfare. So what is the maximum we can have in terms of a welfare increase? It's at most what we gain minus what we lose. So at most this upper bound, this upper bound of the gain minus the lower bound of the loss. So the welfare change or the welfare increase will always be lower than that. You know, once we have it again, we can just calculate it, because this rectangle is just PU minus MC. So this would be MC. So this is just this line segment, and times the change in output here. And similarly for the red area here, similar PU minus MC here, same line segment times the delta Q2, the change, the reduction in output in the strong market. And now it's straightforward because this term we have in both markets, and so the effect whether this delta W is positive or negative depends on this change in aggregate output. So here we increase the output in market 1, in the weak market, and decrease the output in the strong market. And we have an important result. Price discrimination cannot increase surplus unless it increases aggregate output. Okay? Very important result, because now we know immediately with linear demand function, aggregate output is unchanged. That means price discrimination will lead to a decrease, to a reduction in total surplus. Of course, this is only a necessary condition. We will later on see cases with isoelastic demand where we have even an increase in aggregate output, nevertheless, welfare decreases. But this is an important result already. Okay? Okay, and before I move on here with some specific, more complicated parts in terms of new research, I want to jump to slide, what is it? Because I have to do that anyway, to slide 125 here, where I show you why this nevertheless might not be that bad, or it might not be a good idea to ban or to prohibit price discrimination. And the argument here I show you is one which relates to the point that what we assumed up there is that our two markets, our two groups are served irrespective of whether we have price discrimination or not. But this might often not be true because the uniform price is affected by demand in the weak markets. And suppose you have two different markets, and our example will be one where we have a developing country and a developed country. And you have a weak market there with a very low willingness to pay, or ability to pay, okay? And if you want to serve both markets at a very low price, what you might want to do, if you have to serve them at a uniform price, you might want to, or you will perhaps just say, okay, then I only sell my product in the strong market, okay? If I'm not allowed to sell my medical drug at a cheap price in Greece, I only will sell it in Germany. Okay, that's what might be the result. Therefore, price discrimination might be a good thing in that respect, that it allows or will open up weak markets, that it will allow firms to sell their product at a much lower price in markets with a low ability to pay or low willingness to pay. And therefore, the result can be that we get an increase in aggregate output and an increase in welfare, even though we have a linear demand function. And that's what I want to show you by a simple example right now. So suppose we have two countries. The one is the north country, the rich country, and the other is the south country, the poor country. We have both a linear demand with the slope of -1. Maximum willingness to pay in the rich country is 100. In a poor country, it's just alpha times 100. So if alpha is 50% or 0.5, it would just mean that the maximum willingness to pay in the south is 50. And that's what is depicted here. Okay, and if we solve for the aggregate demand, of course, we get the kink here at this cutoff price. Okay, now, suppose you have some marginal revenue. If you have a uniform price, oops, I was too quick. If you have the uniform price, this would be your price, and both markets would be served with marginal cost. Okay, suppose this is an anti-HIV drug, for instance. And the point is here, aggregate demand would just be here this 1 plus alpha times 50 minus Q over 2 in this range below the kink. And if we just do our standard maximization, we get here the equilibrium price, which would be 35 plus 25 alpha. Okay, that's just a standard example, and I think you will have another one or a very similar one in the assignment. Okay, that's rather straightforward. The point, however, is what happens. We assume just a certain value of alpha here now. But now, so this is the dotted line here. I hope you can see that in the YouTube stream at all. Now assume that this decreases. Okay, it goes down. So that would mean alpha is reduced, and therefore you see the kink is now at a much lower price level. And what we see now here is that we have only a single interception here of the marginal revenue curve with the marginal cost curve, and your monopoly price will be, I don't know where it comes here, you will charge the monopoly price of the north, and the south is no longer satisfied. The south, if you have to charge a uniform price, is no longer served. Okay, that's an important point, given that demand in the south is so low, or the willingness to pay in the south is so low. Okay, and what we used here is a rather extreme case. Very often the marginal revenue curve will cut the marginal cost curve at 2 points. That's what you see here and here. Okay, probably I shouldn't have done that. And the point is here now you have, of course, two local optima, the price, this PN, which is a monopoly price if we only serve the north, or this price PU, where we serve both. The question is, what is optimal for the firm? Is it optimal to serve both? Now, we just have to compare the profits, and that's what we can here by looking into how does profit change if we increase output from Q1 to Q2, and you see here increasing it a little bit. Here you see in this range where you have the red rectangle, marginal revenue is lower than marginal cost, so you make losses in this range. But if you move on up to Q2, you see in the other part, marginal revenue is above marginal cost, and therefore you make profits. And what you see here is that in this case, the blue triangle is larger than the red triangle, so it will be optimal to serve both countries. Okay, but of course, if we now move on and would further reduce the willingness to pay in the south, the red triangle, and I don't know where I have it here. Yes, here in this case, I don't have any further triangles, but you see here the red triangle here, which would be the one here, would be smaller than this triangle, and therefore in this case it would be optimal only to serve the north. But that's a bad thing. Why? You as a government tell the firm you have to charge the same price in both markets. That means it will charge a very high price so that only the strong market is served, only the north is served. But this is, of course, completely inefficient, because in the south you have people who would pay much above the marginal cost, okay, and even the marginal revenue is above marginal cost. So if you allow for price discrimination, the firm will be willing to serve also the south. Okay, and I hope I have that here on my oh, I don't have any further diagram here. So what you see immediately, what you would do is you would just as we had it above, you would just have the additional part. I don't know whether this probably isn't the right kind of firm of demand function and marginal revenue functions, we would have to jump back to this part. Okay, here if we allow marginal revenue, you would just sell this as this price here, and here at the high price. And I don't want to reduce it right now here, if you sell it as at a uniform price, you probably will only, if alpha is sufficiently small, you will only sell at a uniform price. And that's a bad thing, because you don't get anything or you don't have any losses by allowing price discrimination here. Okay, if you allow price discrimination, the price in the north will be the same, but now you serve also the south. Okay, and you increase efficiency. And that's something which even the European Court of Justice acknowledged. There was a case some 10 or 15 years ago with the I think it's a British pharmaceutical company, Glaxo. They sold one of their medical drugs in Greece rather cheaply, and they prevented this kind of parallel trade. And of course, then wholesalers complained that they were not allowed to export that part within the European Union. But the European Court of Justice said, no, this might be somehow be okay, because it allows to serve another market with a low willingness to pay. Okay, that's what we have here. And that's what I wanted to tell you here with this respect. And I think this is what is summarized. If I move on here, this is summarized on this slide. Okay, suppose only the north is, that's exactly what I said. Suppose only the north is served with a uniform price. Once we allow also to serve the south with price discrimination, welfare in the north is unaffected. Consumer surplus is created in the south. We open a new market, and profit is also generated in the south. Otherwise, the market would not be open, and therefore we have a welfare increase. So price discrimination increases welfare. And it's this point why economists are rather cautious to say we should forbid, or but we should prohibit price discrimination, because it might always be that some consumer groups would be served with price discrimination. And suppose there is a law that you have to sell a product to all persons at the same price. Probably it would not be, it would be a very high price, and students wouldn't get any discount. Okay, so in that respect, as a student, you always should be in favor of price discrimination, at least if you are interested in your personal well-being. Okay, so this is the main part of this group pricing, of the third price discrimination. I already promised you that we might start with some look into what is recent research, and this recent research goes beyond this kind of linear demand examples. There's an interesting paper by Aguirre, Cohen, and Vickers in American Economic Review in 2010, and they look into more complicated demand structures. And what they said is that the welfare effects depend on the curvature properties of demand functions. If you have available the slide deck I distributed, I added just this part from the notes section. Okay, we call these curvature properties simple, but actually what you see is this is about the convexity or the curvature of the demand function. You see there are always second derivatives of the demand function. You know, with linear demand function, the second derivative is always zero. So there is no convexity or something like that. And they also need the curvature of the inverse demand function, and they get some measure or some point or some expression or some statement on how these measures relate to the price elasticity of demand. I will give you a simple example on the next few slides. The point is here, they come up then with rather complicated rather complicated statements. So what they find is that welfare is higher with discrimination when inverse demand in a low price market is more convex than in the other market, and the price difference with discrimination is small. Does that tell you anything? Complicated, okay? Discrimination reduces welfare when the direct demand function is more convex in the high price market. Again, a complicated statement because you have to look into this curvature. What is now interesting from a general point of view is that in many cases, price discrimination reduces welfare. Remember just our linear demand function or linear demand case we looked up there, but the conditions for discrimination to raise welfare are also not too implausible. Okay, again, remember our case in which we didn't serve the South. So the problem is, and that's where we are at the government, it's so complicated. We don't have an easy statement here. Okay, we don't have an easy statement. Should we prohibit that or not? Okay, and the other thing, if demand is concave in a strong market and less concave or convex in a weak market, then output increases with discrimination. Remember, with linear demand, we always had aggregate output staying constant unless we open up a new market. But here, with these more complicated demand structures, we might even see an increase in output with price discrimination. And that's what I just show you in the following simulation here. I use isoelastic demand functions. Isoelastic demand functions are just Q over P. It's just a hyperbola. Okay? Oh, actually, I could probably draw a nicer one. It's just like a hyperbola. And here just you have some again, the minus here. It's A over P, and here the exponent is just the elasticity of demand. Okay, that's what we have here, and I assume two different of these demand functions. Here, the one demand function has an elasticity of 2. I assume that the marginal costs are 1, and I assume that there's some this scale factor or this market size factor is 100. And what we see here, if elasticity of demand is 2, we got just that remember you have the Amoroso-Robinson relation, which states 1 over 1 minus epsilon. So if epsilon is 2, you get 1 minus 1/2. So you get P over 2 is equal to C, and therefore P is 2C. Okay, that's, you see here the price, marginal cost are 1, the price in market 1 will be 2. Now, what you see here is if we allow for price discrimination, and if we increase this elasticity 2 from say 2, where we have the same prices, of course, to 10. With 10, the price would be just 1.1 about, okay? About 10% markup only. And you see, you get rather different cases. Here in red is the prices under price discrimination. In green is the aggregate or the uniform price. Okay, and you see here it's rather interesting if elasticity increases, the uniform price first decreases and then increases, and in the end you see as the elasticity is rather high, this gets a very weak market, and the uniform prices is almost identical to approaches the price in the strong market. Then what is even more interesting then, of course, is how does that translate in terms of output, or in this case of aggregate output. And now what you see here is in red is aggregate output under price discrimination. Green is aggregate output under uniform pricing. Okay, this would be uniform pricing, and you see here uniform pricing is really bad in terms of output. Because you charge such a high uniform price, people in a weak market are hardly served at all. And this means that the aggregate output is here only half, in a sense, in the case of the uniform price than it is in the case of price discrimination. Okay? Okay, that's only output. So, of course, we are always interested in welfare. That's what we are looking into right now. You see, for a large part, until, say, the elasticity in the weak market is about 5, there is hardly a difference between the welfare in the two markets. Okay, you might say that welfare with uniform prices, the green line is slightly higher, but the difference is hardly visible. Okay, but what you see here, and that's related to what we just had, to this huge difference in terms of output, what we see here is with very high, and we didn't even move on until 10, with very high elasticity, with the weak market being very weak, it's better to allow for price discrimination. Okay? And finally, what about consumers? Of course, total surplus is made up of both profit and of consumer surplus. And you see here in this region here about, obviously, profits are here. Profits are higher with price discrimination, and these higher profits, of course, do not totally compensate for the lower consumer surplus. That's what you see here. Consumer surplus is lower with price discrimination at these kind of medium values of these elasticity. So if the market is not too weak, but if the market is really weak, you see that even consumers in the weak market, or even total consumer surplus, increases. Okay, so again, rather complicated in terms of a decision for politicians. Okay, I now have several further very interesting recent research papers, one by Dirk Bergemann and co-authors. I think I don't have the time to look into that right now, even though I worked a lot to have that, but I think I run out of time and it's rather complicated. I rather want to mention to you one further point in terms of policy, and here is, I think I just move on to the final slide I had here in terms of policy. What we have in currently is a huge discussion on Doppelpreissysteme. It's in German. So actually that you have I should write it in German. So you have two different prices. For instance, I think Bosch Siemens Hausgeräte. So they produce household appliances like refrigerator, like washing machine. They had a so-called Doppelpreissystem. So two price systems. They charge companies a different price whether they sold in their brick and mortar store or whether they sold it online. So if you were MediaMarkt, MediaMarkt is German anyway, MediaMarkt, and you sold a Siemens refrigerator, you were charged a different wholesale price from Siemens if you sold it online than if you sold it in your brick and mortar store. Okay, that's a so-called Doppelpreissystem, and it's a sense, of course, price discrimination, because the online sales channel is discriminated. Of course, why did Siemens Bosch Hausgeräte do that? Because they knew, and there's a huge discussion about free riding and so on, they knew that it's important for so that customers buy their refrigerator, that they can look at this refrigerator and that they get some service in the brick and mortar store, that they get some advice. Okay, and they wanted to give them a higher margin there. And so that you still have brick and mortar stores. But I think they were charged, they were fined by the Bundeskartellamt, and there were similar cases at the European Union from the DG competition. Okay, so here you see it's a complicated thing. I think that it's not too good an idea, or it was not too good an idea of the Bundeskartellamt to prevent or to prohibit this kind of practices, because this, in a sense, doesn't take into account that the manufacturer really doesn't have an incentive to discriminate against a sales channel if it doesn't help aggregate sales. Okay, I think this is a rather complicated topic, a topic where you could well write a master's thesis on, but given that I run out of time, I will be available in WebEx for further discussion, and just want to thank you for being with me today. Again, I'm available for further questions in WebEx, and meet you again next week for the next part of price discrimination, which would be a two-part nonlinear price discrimination. Or actually, it would be second-degree price discrimination and first-degree price discrimination. But with second-degree price discrimination, we speak of two-part tariffs. So to get that straight. Okay, thanks, and see you next week. Bye.